The mass airflow sensor measures the flow of air entering the engine. Combined with the intake air temperature data, the ECM is able to determine the volume and density of the airflow. A MAF signal high DTC will be logged if the voltage or frequency of the MAF output signal rises above a preset limit for a predetermined time. There are two types of MAF signal output: analog, whereby signal voltage is varied based on airflow, or digital, where a generated square wave signal's frequency will be altered based on airflow. A MAF signal high DTC may be caused by an open in the low reference circuit, or a short to voltage or open in the signal circuit. A scan tool can be used for initial testing and diagnosis of the MAF circuit. Altering the engine speed should reflect a change in the MAF data values. If the DTC is intermittent, access the vehicle's freeze frame records for vehicle conditions at the time of the fault. This information may be helpful when you try to reproduce the fault. If the fault is intermittent, turn the ignition on and monitor the scan tool MAF data while flexing the harness between the MAF sensor and the ECM. If the scan tool data value rises while doing this, the fault will be harness related. Sometimes a fault in the MAF sensor may become visible when watching the scan tool data and lightly tapping the sensor with a soft face mallet. If this occurs, the fault is most likely in the sensor assembly. A signal high DTC may even be caused by contamination of the MAF sensing element. These can be cleaned with a designated solvent. Before attempting to test or diagnose a MAF circuit fault, a schematic for the vehicle should be accessed and referenced to for system voltages. But some schematics won't tell you what type of signal circuit the engine management system uses. This is where an understanding of scan tool data is handy. Turn the ignition off and disconnect the MAF connector. Turn the ignition on and watch the scan tool data. If the MAF data value increases to maximum, the ECM uses a pull-up type signal circuit. Connecting a 3 amp fuse jumper across the signal and ground terminals in the MAF sensor connector should change the MAF reading from high to low. If this is seen, the circuit is operating correctly and the fault may be internal to the sensor. If, when disconnecting the MAF sensor, the signal value decreases to its minimum, this is an indication of a pull-down type signal circuit. Connecting a 3 amp fuse jumper across the signal and high reference terminals in the MAF sensor connector should change the MAF reading from low to high. If this is seen, the circuit is operating correctly and the fault may be internal to the sensor. If the MAF data value did not change when monitoring the scan tool data, it's time to break out the multimeter, roll up your sleeves and get to work. Remember to connect a battery maintainer to the vehicle while performing voltage checks. With the ignition off, disconnect the MAF sensor connector and attach the meter between battery positive and the low reference terminal in the harness connector. You should see battery voltage displayed. If the meter displays 0 volts, there may be an open in the circuit. Move 1 meter lead to the ECM connector and back probe the MAF low reference terminal and watch the display. If the meter displays battery voltage here, then there is an open between the two connectors. If the meter still displays 0, disconnect the ECM and inspect the MAF low reference terminal for corrosion and terminal tension. If no fault is found during this check, the open must be internal to the ECM. If the voltage on the signal circuit rises above a predetermined threshold, a signal high DTC will be set. With the ignition on and the MAF sensor disconnected, place 1 lead of the multimeter in the MAF harness signal terminal and the other on battery negative. You should see 5 volts displayed. If the meter displays significantly over this value, there may be a short to voltage in the circuit. Turn the ignition off and disconnect the ECM. Turn the ignition on and watch the display. If the voltage is still present, the short is in the harness between the two connectors. If the meter display registered 0 volts with the ECM disconnected, the short may be in the ECM or another circuit from the ECM. To isolate between the two, perform a continuity check between the signal terminal in the MAF connector and all other terminals in the ECM connector. If continuity is not seen, then a short to voltage in the ECM can be confirmed. With the ignition on and the MAF sensor disconnected, place one lead of the multimeter in the MAF harness signal terminal and the other on battery negative. You should see 5 volts displayed. If the meter displays 0 volts, then there may be an open in the circuit. Move 1 meter lead to the ECM connector and back probe the MAF signal terminal. If the meter now displays 5 volts, the open is in the harness between the two connectors. If the meter still displays 0 volts, turn the ignition off and disconnect the ECM. Inspect the MAF signal terminal in the ECM and ECM connector for corrosion and correct tension. If this is okay, the open must be in the ECM. If you have proved the high reference, low reference and signal circuits are okay, then the fault must be in the sensor itself. Diagnosing MAF circuit faults doesn't have to be hard. Take your time, understand the system you're working on. Training now will prepare you for the future. Thanks for watching.